If you're an IT leader, an SRE, or, well, really anyone wrestling with modern digital infrastructure, you know the reality.
Oh, yeah.
The world is getting just exponentially more complex. We're talking distributed architectures, maybe a mix of multi-cloud providers, microservices.
That scale up and die in seconds.
Exactly. And these massive Kubernetes clusters that are just churning out data by the petabyte.
And that scale, it just produces chaos. Your operational environment becomes this sprawling landscape of log data.
That's everywhere.
It's scattered across serverless functions like AWS Lambda, tucked into API gateways, spilling out of your CI/CD pipelines, even streaming from IoT devices on the edge.
The result is log fragmentation.
Mm-hmm.
And that means you have critical incident data scattered across a dozen different silos.
Which forces manual searches.
And it slows incident response to a crawl. We're facing huge risks to our uptime, to our service level objectives, all because no human team can possibly monitor this volume.
That is the core breaking point. It really is. Traditional monitoring tools, the ones that rely on, static thresholds and regex patterns, they just fail.
They just break.
They break when they're confronted with these unstructured, dynamic log streams. They generate alert fatigue, not intelligence. And this is why AI isn't a luxury anymore.
It's mandatory.
It's a mandatory foundation for operational resilience.
So in this session of the Agentic AI podcast, our mission is to unpack that next revolution in DevOps observability. AI-driven centralized log management.
Which is really the foundational layer for true AIOps.
We are talking about transforming that raw, chaotic data into autonomous actions using machine learning and specifically the emergence of agentic AI.
We'll break down the 6-layered architectural blueprint that makes this autonomy possible, and then we'll get into the quantifiable benefits.
Right. So if you're a decision maker, we want you to walk away from this understanding the precise return on investment this shift provides for your enterprise. Okay, let's get into it. We've established that modern DevOps environments create this vast complexity problem. Logs are coming from every direction. So why is centralization not just helpful, but, as you said, mandatory?
Because without centralization, you just can't see the full picture. It's impossible when your data is siloed.
So when dev teams are only looking at their app logs?
Exactly. And infra teams are only looking at VM logs. You create these massive blind spots. Incident response becomes this manual correlation exercise.
Which means delayed resolution times and ultimately a poor customer experience.
Right. Centralizing means you aggregate all those logs into one stream for real-time analysis.
Okay, that covers the efficiency side. But what about the critical governance aspect? I know for a lot of organizations, compliance is the real driver here.
Precisely. For any decision maker listening, this is paramount. Centralization is, it's non-negotiable for audit readiness.
Mandated by all those regulations.
All of them. We're talking SOC2, ISO 27001, HIS, PCI DSS, especially if you operate in high-stakes sectors like banking, financial services, insurance.
The BFSI sector.
Right. If you can't produce a real-time consolidated audit trail across your entire hybrid cloud, the cost of non-compliance can run into the tens of millions. You need a single source of truth.
That makes the why crystal clear. So let's talk about the leap from traditional analysis to AI. If the old way is static search terms and volume spikes, how does AI fundamentally change the quality of insight we get?
The AI approach, which is driven by large language models, or LLMs, focuses on understanding meaning and correlation, not just volume. And this allows for some really game-changing capabilities. First is something called semantic clustering.
Okay.
So instead of just grouping logs based on an exact keyword match, the AI groups them based on the underlying meaning or intent, even if the phrasing is slightly different across all your microservices.
So it's not just spotting a threshold breach, but actually understanding the context of the error across all these different systems.
Exactly. And that context enables far more accurate anomaly prediction and facilitates what's called chain of thought reasoning for root cause analysis, or RCA.
We hear that term chain of thought reasoning a lot with AI. What does that mean practically in log management?
Think of it like this. A human SRE tracing an issue is sort of following breadcrumbs. An AI using chain of thought reasoning, it acts like a master detective.
Okay.
It doesn't just stop at the first suspicious log entry. It meticulously connects every single piece of evidence across the infrastructure. The app error, the database timeout, the upstream config change, the downstream effect on the load balancer, and it reconstructs the full causal chain.
So it sees the entire story.
The entire story. And this lets teams identify and even predict incidents before they ever impact an end user. You move from reactive firefighting to proactive prediction.
To get that master detective capability, you obviously need a serious structure underneath it, a multi-layered architecture, right?
Absolutely. We've identified a pretty robust 6-layer blueprint required to build a scalable, AI-driven log system.
All right, let's walk through that blueprint, starting at the very beginning, at the ingestion point.
Yeah. Layer 1 is the data collection layer. The primary function here is just universal log shipping.
So getting the data from everywhere.
From everywhere. This means deploying specialized agents. It could be open source tools like Fluent or Logstash or lightweight sidecars in your Kubernetes pods, or even just API endpoints pulling from AWS, Azure, Nginx, Jenkins.
The whole stack.
The whole stack. The crucial factor is real-time, guaranteed delivery of data. You can't have gaps in visibility.
Okay, so once it's collected, we're talking petabytes of data eventually. Layer 2 is the centralized storage. What's required here beyond just a massive database?
Scale and speed are everything. You start with scalable index solutions like the open source ELK stack or OpenSearch, which are fantastic for fast searching. But for the AI to really work its magic, you need specialized repositories.
And you're talking about vector databases.
Exactly.
Can you explain why that's so important?
Yeah.
Why do we need a vector database if we already have something like Elasticsearch?
It's a great question. Vector databases, like Pinecone, for example, are crucial because they store AI embeddings. An embedding is basically a numerical map or a fingerprint of the log data.
A mathematical representation.
Right. So instead of the AI searching for the literal word timeout, it searches the vector space for the concept of an application failure. It groups semantically related events instantly.
Ah, that's what enables that high-speed semantic search you mentioned.
That's the mechanism. And then for long-term retention, for compliance, you leverage cheap object stores like S3. Keep maybe 30 days of data hot and archive up to a year.
Got it. So we've collected the data, stored it intelligently. Layer 3 is where we clean up the mess. Normalization and enrichment.
This layer is maybe the most painstaking, but it's absolutely essential for AI accuracy. We have to standardize the data format.
Using something like the Elastic Common Schema.
Perfect example. And using parsers like grok patterns to extract key value pairs from all that unstructured text.
But surely, forcing standardization across super diverse, multi-cloud logs adds a ton of overhead. Is the AI gain really worth that complexity?
It's true, it's upfront engineering effort, no doubt. But the justification comes from the enrichment step. Standardization lets us inject crucial, contextual metadata.
Like what?
Like the relevant pod ID, the topology map of the affected service, or the user session info tied to that specific event. Without that clean contextual data, the AI's analysis in the next layer is just garbage in, garbage out. The context is what makes the AI smart.
Which brings us to the intelligence core. Layer 4, the AI and analysis layer. This is where the agents start to form insights.
This is where unsupervised learning algorithms work on those embeddings to perform real-time detection. And the unsupervised part is key. It means the AI finds patterns without humans having to define them first.
So it finds the unknown unknowns.
That's the goal. The critical outcome here is building those agentic workflows for RCA. For example, an agent can detect a spike in latency and instantly trace it all the way back to a single specific config file change that was deployed moments earlier.
That proactive, traceable alerting has to dramatically reduce false positives.
It's a massive reduction in noise, a huge force multiplier for engineering teams.
Which leads to Layer 5, the user-facing side. Visualization and querying. I assume we're moving beyond just clicking through dashboards here.
Absolutely. I mean, tools like Kibana or Grafana still provide dashboards, but the game-changing feature is natural language querying.
So you can just talk to your logs.
You can just ask the system.
Yeah.
Because the interface is LLM-based, an SRE doesn't need to be a master of a complex query language. They can just type, "Show me all 500 errors related to last week's deployment in the West Coast region that resulted in customer complaints."
And an AI copilot can help drill down from there.
Instantly.
And finally, Layer 6. The destination of Agentic AI, the automated action layer. This is where the system stops just informing us and actually starts fixing the problem.
This is where autonomy truly manifests. Agents, acting on the insights from Layer 4, are authorized to trigger remediation actions.
Like what kind of actions?
They might autonomously execute a change rollback, automatically scale up resources to handle an unexpected load, or apply security patches to a newly identified vulnerability.
And they have to integrate with tools like Jira or ServiceNow for ticketing.
Seamlessly.
Yeah.
And notification systems like PagerDuty. But governance here is absolutely key, as you said.
Right. You need to be able to run these agents in a strictly controlled approval mode for high-stakes tasks.
While allowing full auto mode for routine stuff like database cleanups or rolling back to a known good configuration.
That control loop is the difference between a smart tool and a trusted operational partner.
It really is. Agentic AI transforms DevOps by deploying autonomous agents that monitor and act in real time without constant human intervention.
Let's drill down into those autonomous use cases. For a decision maker listening, what are the specific applications that deliver immediate value once this architecture is up and running?
The first, and honestly the most compelling, is autonomous RCA. By using that chain of thought reasoning, agents pinpoint the exact root cause, and they can cut mean time to resolution MTTR by hours.
So instead of a 4-hour war room meeting,
The agent provides the answer in minutes. Second, cost anomaly detection is huge. The agent analyzes cloud usage logs continuously and can detect and predict significant overspending before the monthly bill even arrives.
it's flagging unused resources or inefficient scaling loops.
Exactly. It's turning your logs directly into quantifiable money saved.
What else?
Other critical functions are things like deployment failure prediction, where an agent reviews CI/CD logs and staging to predict risk before a release goes live, or config drift detection, comparing current logs against a baseline, and, most dynamically, self-healing workflows.
Give us a more tactical example of self-healing. How does that payoff actually manifest in a busy network operations center?
Okay, think about service overloads in a microservices environment. A famous case, often cited, is how huge platforms like Netflix manage traffic spikes.
Right.
Imagine a team member doesn't even know there was an overload. Why? Because the AI agent, noticing the service degradation logs, autonomously rerouted traffic away from the overwhelmed cluster and initiated an auto-scaling event, all before the service level dropped below its threshold.
So the human engineers only brought in for completely new failures, not routine chaos.
That's the promise of platforms enabling no-code deployment of these agents. Automated, instantaneous remediation of known issues.
That brings us to the ultimate payoff. Let's summarize the key business advantages for anyone looking to budget and implement this system.
It really all boils down to four main things: speed, focus, reliability, and savings.
Let's start with speed.
We consistently see MTTR cut by 50% or more. We're talking resolutions moving from hours down to maybe 10 or 15 minutes.
Okay, what about focus?
The system performs a radical noise reduction. By filtering out non-critical alerts and clustering them into single incidents, you can filter up to 70% of the alert volume.
So your engineers only see high-impact, actionable items.
Precisely. Then there's reliability. This is the key metric for customer trust.
It is.
Increased observability across the full stack drastically improves uptime. It lets organizations realistically target that 4-9's goal, 99.99%.
And finally, savings.
Savings are realized through optimized cloud usage and smart storage retention, which can result in cloud bills being reduced by 20 to 30%. Plus, of course, increased scalability without needing to proportionally expand your human ops team.
This all sounds genuinely transformative. But like any major architectural shift, especially one involving AI, there have to be serious practical challenges. We can't gloss over those.
No, absolutely not. The first hurdle is just the sheer data volume explosion. Terabytes, even petabytes of logs are straining storage budgets.
So what's the mitigation?
It requires a disciplined approach. Aggressive data compression, smart filtering at the collection layer, and well-designed retention policies that define what stays in expensive hot storage versus cheap archival storage.
And the second risk, maybe the scariest one, is the cognitive risk. Model hallucinations. The AI misinterpreting data or drawing false conclusions.
That's a primary concern. How do you trust an AI that might occasionally, well, lie? Mitigation demands robust governance frameworks and essential human oversight.
You need a human in the loop.
You must have hybrid human-AI workflows. For critical decisions, like rolling back a major database schema, the system has to implement a trust score for its own prediction. If that score is low, it must require human approval before it acts. We can't just trust the machine without a safety net.
What about securing all this centralized, highly sensitive data?
Major security boundaries are mandatory. Centralizing logs increases your attack surface. You have to have robust role-based access control, or RBAC, to ensure only authorized people can see specific data streams.
Especially logs with PII or financial data.
and mandatory end-to-end encryption on all data, both in transit and at rest. It's non-negotiable.
And finally, the cost of running the analysis itself. AI compute isn't free.
Correct. Cost management for that AI compute layer can get expensive, especially with LLMs running continuously. Optimization is key. Organizations should leverage serverless compute options so the analysis layer can scale down aggressively when it's not at peak load.
So you only pay for the compute you actually use.
Exactly.
For those listening who are ready to start planning, let's quickly survey the current market landscape based on the architecture we've discussed.
Sure. You have sort of three major approaches. First, the ELK stack Elasticsearch, Logstash Kibana. That's the open source stalwart.
Its strength being cost effectiveness in search.
Right. It's strong for integrating embeddings and custom AIOps models, but it does require significant in-house expertise. There's a steep learning curve.
Then you have the enterprise solutions.
Precisely. You have Splunk, which is known for advanced analytics, massive scale, and strong compliance features. It's excellent for complex ML-based RCA, but historically it comes with a very high licensing cost.
And the alternative.
Datadog offers unified monitoring across metrics, traces, and logs. It provides real-time visibility and has built-in AI anomaly detection, but you have to be mindful of potential vendor lock-in when you choose a unified platform.
So the choice really depends on your complexity, your existing tech stack, and of course, your budget.
Exactly.
This shift, it really represents more than just a new set of tools. It's about transforming raw operational data into a true strategic asset.
It is. Moving toward intelligent autonomy is rapidly becoming a competitive requirement for any high-performing enterprise. AI-driven centralized log management is the foundational prerequisite for that.
And looking ahead, the sources all seem to point to specific trends that will define operations by 2025. We're talking about the full emergence of autonomous DevOps.
Yes. We will see agentic AI SRE assistants handling self-healing systems end-to-end with minimal human interaction. Look out for predictive SLA service level agreements that can actually forecast your system's uptime based on current log health.
And AI governing cloud costs proactively.
The goal is truly predictive operations, all driven by autonomous agents.
But the journey to that autonomous future has to start somewhere. And so we want to leave you with this provocative thought based on the implementation path. The first step isn't choosing the tool, it's assessing your operational maturity.
You need to audit your current logs for gaps in coverage and compliance.
So we leave you with this question. What is the biggest blind spot in your current log management maturity that agentic AI could instantly solve? And more importantly, what is the cost of leaving that blind spot unaddressed for another year?
Thank you for joining us on the Agentic AI podcast.